Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Muhammad Zamani. My SW is Dr. Fazli and co-SW is the Khairi. My FIP title is the Assessment of Shallow Water Bathymetry in the Kuala Muda Coastal Area using Sentinel 2A satellite imagery and nautical chart.
Coastlines are always shifting, right? But mapping those underwater depths globally, it's been a massive unsolved headache. To actually map the entire globe, scientists realized they had to look up to satellites. This unlocks our ability to understand coastal mysteries on an absolutely massive global scale. Just recently, researchers mapped a continuous 4,000 kilometers of the West African coastline using this exact tech. It created this insane mosaic from Senegal to Gabon, revealing flow channels and river deltas like never before.
Plus, deep learning networks are now combining these wave kinematics with color data for ultimate precision. It's wild.
The new era is here. We finally have the power to continuously monitor our coastlines globally.
Okay, continue on. This is my specification of Sentinel 2 Level 2A. As you can see here, my data is from 10 January 2025. Cloud cover is 16%. And then we move on to objectives. I have two objectives, which is to determine the depth of Kuala Muda coastline using satellite imagery to validate the accuracy of the imagery-derived bathymetry results against available nautical chart data using statistics. So for my study area, okay, so this is my demonstration of my study area. Approximately my coastline is 140 kilometer. So next is for the methodology. In my methodology, there's 4 phases, which is first is the phase 1, which is about the selection of the study area and the selection use of software. Then the second one is the data collection, with involve 2 data, which is the Sentinel 2 and nautical chart for this work. Third one is phase 3 data processing, which involve a lot of this work, mainly from a DAS and then also a ArcGIS Pro. Okay, the last one is phase 4, which is result and analysis. In this part, involve a lot of work from ArcGIS Pro and Excel to get the 2 objectives that I am aiming for in this work. Okay, for phase 1, the selection of Kuala Muda, which is basically the study area, selection use of ADAS, ArcGIS Pro, and Excel, which is the 3 software that I choose to do this work. Okay, moving on. Okay, phase 2 data collection, Sentinel 2 level 2A that I got from Copernicus, nautical chart that I buy from the National Hydrography, which costs like 180 ringgit. Okay, phase 3 data processing, layer stacking using 20 meter resolution, band 2, band 3, band 8A. After that, doing the NDWI, then doing the threshold value, spatial filtering by doing the low pass 3x3s, all this from a dust. Then georeferencing the nautical chart, then extract sounding point from the nautical chart by digitizing the point in ArcGIS Pro. So that's basically the work from phase 3 data processing. Okay, continue on. Okay, for phase 4, we continue from phase 3, which we do the band ratio, which is we apply the formula ln band 2 divide band 3 in the raster calculator in ArcGIS Pro, then overlay nautical chart. After that, I identify M0, M1 by run regression in Excel. Then you can finally do the final result, satellite derived bathymetry, then doing the accuracy validation. Okay, for the result, I have like a couple. First one is the NDWI, which stands for Normalized Difference Water Index. This is the layer stack of band 2, band 3, and band 8. And I choose the 20 meter resolution for Sentinel 2 to do this work. Okay, next one is the result, which is the band ratio, which is generated from the STAM model, a STAM band ratio model, where the logarithmic ratio of Sentinel 2 and band 2 and band 3 was computed using the formula ln band 2 divide band 3 in the raster calculator in ArcGIS Pro. Okay, this is the summary output regression statistic. This is to identify M0 and M1. M1 is the 616.29, and M0 is the negative 604.79. And you can also see my standard error RMSE, which is 2.97. M1 and M0 is the coefficient under there, as you can see under there. So that's basically it. Continue on. Okay, the next result is the derivation bathymetry from Sentinel 2. As you can see here, this is generated by applying this formula. As you can see, we already identify M1 and M0. So basically, M1 times bend ratio plus M0 in the raster calculator in ArcGIS Pro, then you get this. After that is to do the accuracy assessment, which is finding the R square to validate this work, which as you can see on the right there is 0.66, which is acceptable. Okay. Okay, next is the conclusion and recommendation. I have not much to say. I have 3 points here, which you can see here. I have already mentioned. For the recommendation, I pretty much recommend that future research should be explored, such as machine learning regression to improve accuracy in this type of work. So thank you for watching my presentation.